Number 26. Find the x values of all points where the function has any relative extrema. Then find the values of any relative extrema. So to do this, we find our derivative, f prime of x. If we take this derivative, the derivative of negative 3 will be 0. So I'm going to have a negative times the power times the base to the power minus 1. So that's going to be negative 1/3 x to the negative 2/3. Because 1/3 minus 3/3, which is 1, is negative 2/3. So that's going to give us a negative 1 over 3x to the 2/3. Now, as we saw in a previous example, sometimes a derivative doesn't have a value that makes it 0, but it may have a value that makes it undefined, and that is also a critical number. So since this numerator is never equal to 0, that doesn't cause a critical number, but when the denominator is equal to 0, that will. So dividing both sides by 3, x to the 2/3 is 0, means x is 0 is a critical number. So we'll place that 0 on the number line, and we'll check a number to the left, like negative 1 is a test point, and a number to the right, like positive 1, is a test point. And we need to check that in the derivative. So f prime of negative 1 is negative 1 over 3 times negative 1 to the 2/3. And then f of positive 1 is going to be negative 1 over 3 times 1 to the 2/3. Now here we got to be really, really careful. I think f of 1 is pretty obvious that this is going to be a negative 1 over a 3 times 1, because 1 to any power is always 1. So that's a negative 1/3. But over here, f prime of negative 1, we got to be careful. Negative 1 to the 2/3 means the cube root of negative 1 squared. So that's a negative 1 squared, which is a positive 1. So this is also going to be negative 1 over 3. Now, as you can see, there is no opportunity for this function to change from a negative to a positive or a positive to a negative, because it's decreasing here and it's decreasing here. So there are no extreme values or no extrema for this function.